Okay, as promised, let's do some examples for solving exponential and logarithmic equations. All right, so let's start off with a slightly easy one, or easier one, right? So if we said, for example, 3 to the x equals 27. Now exponential equations, if you can get the base the same, for example, 3 to the x equals 27 is 3 times 3 times 3. The bases are the same, we can get rid of them. We can simply have this conclusion that x equals 3. If we make things a little bit more complicated, what if I said to you 5 to the negative x equals 125? Well, I know that 125 is 5 times 5 is 25 times 5 is 125. Negative x equals 3. I like x equals 3, right? X in this case would equal negative 3. How about, what if I said, what if I said 4 to the x plus 2 equals 8 to the x minus 1. Now we're a little more complicated, right? We've got to get these in terms of the same base. Well, we know that's 2, right? So we have 2 squared raised to the x plus 2. And 8 we know is 2 cubed raised to the x minus 1. Now the bases stay the same, so we can get rid of them. But we're left with, have to be careful, 2 times x plus 2 equals 3 times x minus 1. So now we're down to algebra. 2x plus 4 equals 3x minus 3. Select all of our like terms. We say 2x minus 3x. We get a negative x on this side. We subtract 4 from both sides. We end up with a negative 7 over here. So our solution is, whoops, not plus, x equals 7. I didn't box my other ones. I always ask you guys to box your answers, so I should box my answers too, right? Okay. Well, what happens if the bases are not the same and you can't get them that way? What if I said, for example, 4 to the x minus 6 equals 12? Well, if we can't get the bases the same, then we have to use our friend the logarithm. So this tells us what the base of our log is going to be. Say the log base 4 of 4 to the x minus 6. Whatever we do the left side, we do to the right side. So we say the log base 4 of 12. Okay. Just bring the x minus 6 forward. X minus 6 times the log base 4 of 4 equals the log base 4 of 12. Now we know the log base 4 of 4 is 1 because there is exactly one multiple of 4 in 4. Now I have x minus 6 equals the log base 4 of 12. X is going to equal, while it may not be pretty and may not be something you're used to, simply going to equal the log base 4 of 12 plus 6. Now, typically I would write this as 6 plus the log base 4 of 12. These are the same answer, but this way you don't get tempted to say this is a log base 4 of 18. This is a number, and this is a number. This number is a little bit less than 2, a little bit greater than 1. So if you were to approximate this, I would say it's probably somewhere around 6 point something, right? Excuse me, 7 point something. You can figure that out by plugging it into your calculator if you wanted to, right? You could say this is 6 in your calculator plus the log 12 divided by the log of 4. Now remember, that's me using that change of base formula where you take the one across the top and that goes in the numerator and the one across the bottom goes in the denominator. All right, So that would give you something probably around 7 point something. Anyway, this is what you do. This is kind of your example for exponential functions. All right, well, what happens? Let's do another page here. What if we wanted to talk about log functions? Let's do some basic log functions. All right, new page. What if I said to you, I don't remember what number I'm on, so we'll start over. Number 1, we'll say the log base 3 of x plus 7 equals 12. Ooh, okay. Well, only way you get rid of a log is using its inverse. So whatever this guy is here, make a really big one, and we put it underneath both sides. This cancels out, and we're left with x plus 7 equals 3 to the 12th. So x must equal whatever 3 to the 12th is minus 7. Now, I don't have a calculator with me, so I'm going to leave it up to you guys to determine what 3 to the 12th would be. Well, what happens if, second one, let's try. What happens if you have the variable in the base? So we have the log base x of 12 minus x equals 2. Doesn't matter if this is a number or a letter. We're still going to make a big old x down here and a big old x over here. This will cancel out. We'll end up with 12 minus x equals x squared. And now we have a simple quadratic to solve. I'm going to move these guys over here and say this is x squared plus x minus 12. So if we go up here, x squared plus x minus 12 equals 0. So if we factor that out, we get a 4 and a 3, right? 4 and a 3. This guy needs to be positive. This needs to be negative. So I end up with x equals 3 or x equals negative 4. Now, logarithmic functions you have to check, right? We have to make sure that neither one of these result in taking the log of a negative number. If I were to put 3 in there, I'd get 12 minus 3, positive. Log base 3 of 12 minus 3, no problem. The log base negative 4. Now, well, we have 12 minus negative 4. That's a positive number. That base of a negative 4, you really can't take the base has to be greater than 0. So this guy goes away. We're left with our only solution being x equals 3. Okay. Oh, let's try this one. This is a good one. What if I said to you the natural log of x equals the natural log of x minus 1 plus the natural log of 4. So now we've got more than one logarithm, right? So we've got to combine them. So we can leave this one alone over here, the natural log of x. But over here, we have to use our properties to combine these two. This becomes the natural log of x minus 1 times 4. So now we have a single natural log on either side of the equal sign. So now, remember, the natural log is a log base e. So we put big old e's on either side, cancel out. On the left-hand side, we get an x. On the right-hand side, we get 4 times x minus 1. So x must equal 4x minus 4. So negative 3x equals negative 4. Therefore, x must equal 4/3. 4/3, if we plug that back in there, 4/3 is greater than 1. So 4/3 minus 1 is still positive, so we're good. This is our answer. Okay. Let's do one more kind of complicated log, and then I'm going to introduce you to the idea of quadratic in form, where we combine these two. So how about, let's do the log base 2 of 2x plus 1 minus the log base 2 of x minus 3 equals 2 times the log base 2 of 3. So when you start out with logs, the first rule is combine, combine, combine. So on the left-hand side, we're going to have the log base 2 of 2x plus 1. Since this is a minus sign, that means divided by x minus 3. On the right-hand side, we've got to put this exponent back up here, right? So you're going to have the log base 2 of 9, 3 squared, right? Now that we've got a single log on the left and a single log on the right, we use our big old 2's. Cancel out the logs. So we're left with 2x plus 1 over x minus 3 equals 9. Multiply both sides by x minus 3. And we are left with 2x plus 1 equals 9x minus 27. So 2x minus 9x equals negative 27 minus 1. So we end up with negative 7x equals negative 28. So x must equal 4. Okay, if we go back up here, 4 minus 3 is 1. 4, okay, we're good. This checks out. Let's switch gears here for a second and talk to you a little bit, or give you some examples of something called quadratic in form. Now you will remember, hopefully, from your lecture what quadratic in form means. I'm going to do some examples here. If I say 2 to the 2x plus 2 to the x plus 2 minus 12 equals 0. And I ask you solve for x. Well, first thing you're going to note is that we've got 2 to the 2x, which says, this is probably going to be quadratic in form. So I can rewrite 2 to the 2x as 2 to the x squared, right? Because 2 times x is the same thing as x times 2. I can also rewrite this guy as 2 to the 2 times 2 to the x. Because remember, if the base is the same, you can add the exponents. So if you add the exponents, you can also go backwards to this one. Minus 12 equals 0. So now what I'm going to do, I'm going to substitute for my 2 to the x. I'm going to say this is a squared plus 4a minus 12 equals 0. So what I've done here is I've just said a is the same thing as 2 to the x. Now this we can factor, no problem. It's much easier to see. We have an a here, we have an a here. We want the difference between the factors to be 4. So we've got a 6 and a 2. Now the 4 is positive, so this is going to be positive, and this one's got to be negative, right? So now I get a equals 2, or a equals negative 6. One more step. This is 2 to the x equals 2, or 2 to the x equals negative 6. Now remember, 2 to the x, any exponential function, cannot equal a negative number. So we get rid of that one right away. And now we have a nice simple problem. If 2 to the x equals 2 to the first, x must equal 1. So that kind of gives you an idea, or gives you an example of quadratic and form. Now, you'll get a lot more help or a lot more practice with these on the homework. I hope these lectures have helped.